Good morning, dear students. In the last video, we have seen the last group, that was carboxylic acids, right? So here is the first derivative of carboxylic acid. It is the esters group, where carbon double bond O, single bond O, and R, that is alkyl group. And here dash, it means there is a continuation in the linkage with the parent chain, right? So the suffix used for the esters is little different. In most all these groups which we have seen, alcohol, so in the name OL is there, so we took alcohol, aldehyde, so Al we have taken, carboxylic acid, so oic acid we have taken, right? Ketone, so on we have taken. Now but here ester, we are not taking ester, not es, not ter, but it is little different than the others. It is taken suffix oate, oat. Its naming system is also little different than the other. One more group is there, ether. It is also little having differentiation. So let us first see here the example. CH3 C double bond C double bond O, O CH3. When in a molecular formula, if it is written like this, C double O, then there is one of the carbon linked with double bond O, right? Here ester is the functional group, CH3 C double O, right? And CH3. So ester here is the functional group, and one of the attached is the alkyl group. So first is to be separated ester group and alkyl group. So here I have separated CH3 C double O, CH3 plus C double O minus. So here they have plus and minus attached, and this is CH3 plus, so there will be the further attachment. So we will separate them here, CH3 C double O, and then the alkyl name will be the prefix. So if we have separated this, that means the C double O is along with this CH3, then we will see that R, which alkyl group is this, it will take prefix, right? Prefix will be the first, then root word, and the suffix will be the ester's name, correct? So here what is C? In CH3 C double O, CH3, this is the part 1. So root word as per the carbon atom. So here one carbon and one carbon of the ester group. So total 2 carbons. So it is ethane, right? And part 2 is the alkyl group, 1 hydrogen less than the alkane. So instead of CH4 methane, it is 1 hydrogen less CH3, so methyl. It will take prefix. And then C double O dash, that is the continuation chain and the alkyl group. So that is the functional group. So OATE, OAT, it will take the suffix. So what we will do? Prefix, root word, and the suffix. So here prefix is methyl, root word is ethane, and suffix is OAT because ester group. E and O, both the vowels, so skip E and you will get methyl ethanoate, right? In the same way we have here CH3 COO CH2 CH3. So this is the CH3 COO. Let us consider these as the ester group, right? COOR. So this is our alkyl chain. So alkyl chain will be considered as the prefix. How many carbon? 1 and 2. So it is it. Then primary suffix will be ane because the single bond, ethane. And now here hydrogen is 1 less. So it is alkyl group. So ethyl. Here also 1 carbon, 2 carbon, so ethane, and it is COO. So functional group is ester, so OAT. So it will be ethanoate, ethyl ethanoate. Clear? So this is how we are supposed to give the names to the different functional groups. Now the second derivative of carboxylic acid is amides. R, alkyl group, CONH2. Right? So CONH2 will be the terminal group and R is the linkage of the parent chain, alkyl chain. It is also terminal group, so its position is given number 1 in a parent chain. So when in a chain we see CONH2 at this terminal or this terminal, then from where the functional group is there, that carbon will be considered number 1. And its name is given suffix amide, AMIDE. Amides are the smallest unit of the proteins. They are called amides linkage. The proteins which is helpful for our growth, for repairs of our cell, right? That proteins consist the amide linkage, and CONH2 is the smallest unit in the amide linkages. That is, the proteins are the macromolecules, a complex linkage of the different compounds in which amides is also the participants. Biology students, I think so you might be knowing much more about this, right? The example let us see now here, Ca3CONH2. So here, how many carbons? 1 and 2, right? So this is the one carbon, this is the second carbon. So if we consider root word, then it is ethane, right? And NH2 is attached group, so it is amide. So it will be ethane amide. E and A both vowels, so E will be skipped and the name is ethanamide. Same thing here, 1, 2, 3 carbon, right? And we will consider first carbon where the amide group is attached, CONH2. So 1, 2, 3, it is 3, that is prop, single bond in, and amide group, so propanamide. Clear? The third derivative of the carboxylic acid is carbonyl chloride, RCOCl. CO carbonyl, Cl carbonyl chloride along with the alkyl chain. So here CO is having double bond. When it is written here in the middle, don't worry for it. RC double bond O Cl. We have written when first we have discussed all the groups. It is also terminal group, and here also the group where the COCl is attached. From there the first carbon is considered, and it ends in the suffix oil carbon, carbonyl, so OYL, oil chloride. Now let us see the example so you will easily understand. Ca3COCl. I just told it is also terminal group, and the number of carbon is considered first where the group starts. So C starts from here, COCl. So this is the first carbon, 1 and 2 carbon. So ethane is the root word, and here carbonyl chloride, so it will take suffix oil chloride. So ethane oil chloride, O and E both vowel, E will be skipped, ethanol chloride. In the same way, 1, 2, 3. So prop, single bond A, propane, but COCl, so propanoil chloride. Here you see 1, 2, 3, 4, 5, 6. Hexanoyl chloride. So these two you are supposed to give the names. Now let us see the next group, that is nitriles. It consists dash, it means linkage, parent chain, carbon, triple bond N. It is, you know, that is CN is having C triple bond N, right? So in according to IUPAC we say C triple bond N is a nitrile group, but in general we do say it as a cyanide, right? And it takes suffix nitrile itself, in as in amide, here also nitriles. Let us see the example, Ca3CN. Here also the carbon of the nitrile group CN. This carbon is considered as the first carbon of the given organic compound, and when it is written CN, but it is having triple bond, because here C linkage will be there, then C triple bond N, then only the 4 tetravalency of the carbon can be considered. See, actually if we see the structure, then it is like this, C H3, 1 2 3 H, C carbon C. Now if this is only the C, what about the N? So here one N. What about the another two? So that is the bond of C and 1, 2 and 3. So if we see the carbon tetravalency, this carbon is having 1 here sharing, 2, 3 and 4 here sharing. So our 4 sharing valence electron is completed, and nitrogen 3 sharing also is completed. Clear? But when it is written here, we must understand that the valence is completely over, right? Now see here 1 and 2 carbon, so ethane root word, right? And CN group, so nitrile, ethane nitrile. But again here N and here N, so both N together we will not consider. So IUPAC has decided E also to be skipped, and E, so it is ethane nitrile, ethane nitrile. Clear? Now let us see here carbon 1, 2, 3, so prop, and CN group, so propanitrile, right? The next functional group is amines. So dash NH2, it means NH2 is linked with the parent chain. It is non-terminal FG, that is functional group. It is non-terminal functional group and takes suffix amines in the naming. Non-terminal, that means it may be in the mid of the parent chain, it may be on the terminal position. So CH3NH2, here only one carbon and NH2, so root word is methane, suffix is amine, EA both vowels, so E skip, methanamine, right? Now here also see one amine is attached to this carbon, so the terminal where the functional group is attached, that carbon will take first position. So here this carbon will take position 1, 2, 3. So it is propane, right? And amine group, so propanamine. Why I am telling this? Because here just we are discussing only the linear chain and only a single group. But when we will proceed to further and when we will complete all the rules, then at the same time one organic compound may consist of 2 groups, 3 groups. At that time we will have to see the most active functional group, and from there the numbering will be taking place, right? So all this we have to take place, because almost we are going to learn now all the rules in 11th standard. In 10th standard we have learned few, where to give number, this and that, but here for that reason I am again and again telling that number of carbon will be from or towards the functional group. Here now see functional group is here, so this is 1 carbon, 2 and 3, so it will be prop. Clear? But here the prefix, which prefix? Primary prefix now, because we need to see in primary prefix bond. Here all were the single bond, but here double bond is there, so it won't be propane, it will be propene and amine. So this is propenamine. Clear? Now certain functional groups are there which becomes non-main group, or they are substituents, or they are alkyl chain, then they will take position as prefix. So prefix can be substituent functional groups or they may be alkyl chain. Prefix takes previous position of the root word, that means they are previous to the root word. So first will be prefix, then root word and then the suffix. The common prefixes we are using, it is F for fluoro, chloro, Cl, Br bromo, I iodo, NO2 nitro. But instead of NO2, if it is NO, then nitro so, CH3 methyl, C2H5 ethyl, all alkane. If one hydrogen less, then instead of ane, they will be yl, propyl, butyl, right? And how we will give the name to them. So to write the name of any organic compound, the generalized form is first prefix, then root word, primary suffix, secondary suffix. And while writing the name, first letter of prefix will be capital, then all other small letters. If prefix is not there, then the root words first letter will be capital and all other small alphabet. Carbon atom having functional group is given first number, just in the previous examples we have seen. Then the substituent functional group's number accordingly is written in the name. Accordingly, that means what functional groups are present. Accordingly we are going to write. Before prefix, separating by hyphen. So functional groups number, that means on which number the functional group is present. right? That number we are writing, and it is before prefix, and the number and prefix are separated by hyphen. If functional group is at first position and not mentioned in the name, then also that name is correct. So this is one excuse given by Dipole, that on the first carbon if functional group is there and if number 1 is not given there in the name, then also it is considered correct. Let us see here is example. CH3, CH, CH2, CH2, OH, and here is one branch, that is Cl. So as per the prefix Cl, so chloro will take place. Now let us see the carbon number. Now here we will start from here also 1, 2, 3, 4. Here also 1, 2, 3, 4. But just now I told that number of the carbon will be given 1 where the functional group is there. So alcohol is the main functional group. Actually Cl also stands in halogen. That is also functional group, but alcohol is more stronger than halogen, or we can say more active than the halogen. So first chance is given to alcohol. So this carbon will be first, second, third and fourth, right? So now we will see on third carbon we have chlorine. So prefix will be chloro. Root word is 1, 2, 3, 4 carbons. So but, all single bonds. So in, right, primary prefix and primary suffix, and then see here I have written P, but it should be suffix, secondary suffix, primary suffix, right? And OH, it is alcohol group, so secondary suffix is on. So name will be chlorobutanol. Now here we can see that alcohol is on first carbon, so we will have to write third chlorine. So 3 hyphen chlorobutanol. First capital, all other small. Or we can write 3 chlorobutane hyphen 1 hyphen all. So in butanol, where is alcohol group? On first carbon. So it is 1 all. But as I told, if it is on first carbon function group and if we don't write 1 and if we write directly like this, then both are the correct way of writing the names. Now let us see the rules for IUPAC nomenclature for branched chain, and that is first for the alkanes, single bond. First rule is longest chain rule. Now see here, the longest chain in a compound is taken as parent chain, according to which root word is given. Right? When I started nomenclature, I told root word is given according to the longest chain. See here an example, CH3, CH2, CH2, CH. Branch is here, CH, CH3, CH2, CH3. Now if we see here, then there are 3 chains possibility. Let us see which are they. If we see a whole compound, this is the whole compound, then see 3 ways we can consider the chain. 1, 2, 3, 4, 5. We will have to consider continuous chain. See, don't see like this. 1, 2, 3, 4, 5, 6, 7. No, here it is not continuation. 1, 2, 3, 4, 5, 6, 7. No continuation. So we will have to consider continuous chain. So this is the first. 1, 2, 3, 4, 5. I have shown separately also. 1, 2, 3, 4, 5. Okay, let us see from this side. 1, 2, 3, 4. Here 1, 2, 3, 4. And let us see this side. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So this is having 5 carbon continuous, 4 carbon continuous, 5 carbon continuous. So this is the third chain. 1, 2, 3 possibilities are there. But longest is the 6 carbon. So we'll consider third one. The longest chain may or may not be the straight chain. Here it is straight chain. Clear? Longest is the straight, but all time it may be straight, may not be straight. Let us see even more example. See here CH3, CH2, CH, CH3. This is a single chain. From this carbon again one branch is there, CH2, CH2, CH3. If we see this, here also there are 3 to 4 chains possibility. The first one is CH3, CH2, CH, CH3. This one, 4 carbon. Right, one more is CH2, CH2, CH3, 3 carbons. I have not separately mentioned. So this is 3 carbons. This is 4 carbons. One more you can see here. 1, 2, 3, 4, 5. 5 carbons. Right? And one more you see now. 1, 2, 3, 4, 5, 6. 6 carbons. So there are 4 possibilities. 3 carbons, 4 carbons, 5 carbons, and here we see like this steps, that is 6 carbons. So here also we will consider the longest chain which is having 6 carbon, but it is not a straight. See here, this is straight, but this is not straight. Here then we will have to branch down, right? So we will have to consider longest chain. It may be straight, it may not be straight. Then what happens to the other? If I consider this from here to here, then what will be this one? It will be the substituent. If we consider this is the longest chain, then what is this? It is the substituent. Here also see, we have here also 4 to 5 chains possibilities are there, but we are supposed to consider maximum number of carbons, and there are 9 in a continuous longest chain, so it is to be considered, and the other chains are considered as the substituents. Let us see here. See, this is the chain. First we will see the straight chain. 1, 2, 3, 4, 5, 6, 7. 7 carbon. Okay. 1, 2, 3, 4, 5, 6, 7. Here also 7 carbon. Okay, one more. 1, 2, 3, 4, 5, 6, 7, 8, 9. And if we consider this 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. And 1, 2, 3, 4. See how many possibilities are there. But the longest one is 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is what we have come across. 9 carbon. Now what happened? If we consider this 9, then this is one branch, a substituent group. Here also this is one branch, substituent group. So we will have to give name accordingly. The position of the substituent is to be considered. Now how this position will be given? Here also it is in the branch. Here also it is in the branch. So for that we will have to consider the lowest number in the parent chain. The position of substituent is given lowest number in the longest chain. That is, longest chain should be given number accordingly from both the sides. Right? If I am talking for this, let us first see the simple thing. CH3, CH, CH2, CH2, CH3, and this is the branch. This is A position. Here also same thing is shown, B position. Why A and B? See, here I have considered number from here. 1, 2, 3, 4, 5. No functional group. All are carbon members. So I have started from here. And here I have started from here. 1, 2, 3, 4, 5. Now if we see branch here, it is on the second carbon. And if we see branch here, it is on the fourth carbon. So what is to be given as a position of substituent? The lowest number from either side. So if we consider from this side, it is second. From this side it is fourth. So we will have to consider the lowest number. So A is to be considered. So name given is number hyphen prefix plus root word primary suffix. Sorry, today I have written everywhere prefix. But this is primary suffix. This is secondary suffix. Clear? So what is the number now? 2 things added. Number, then hyphen, prefix, root word, primary suffix, secondary suffix. So here, where is the branch? Second carbon. So 2. Substituent group is given for prefix. So what is this? CH3. 1 hydrogen less than methane. So alkyl. So methyl. And then 1, 2, 3, 4, 5. Pent. All single bonds. So ane. 2-methyl pentane. Clear? Let us see one more. 1, 2, 3, 4 carbon. 1, 2, 3, 4, 5. 5 carbon. 1, 2, 3, 4, 5, 6. So 6 is the hexane. And if we consider here 1, 2, 3 on third. 1, 2, 3, 4 on fourth. So we will go for the 3. So 3-methyl hexane. Clear? So from this we can have the name of this compound also. I hope you will try this. Or let me help, because two substituents are there. Now from here we will see 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5. 5, 6, 7. 5 and 7 are having substituent. Now let us see. 1, 2, 3, 4, 5. So one chance we got, that is 5 and 7 substituent, right? And another is 3 and 5 substituent. So we will have to select the lowest one. So what will be our number now? See here. Third, we are not going to select this because it is greater one, 5 and 7. So this is not to be selected. We are supposed to select lowest one, 3 and 5. So on third carbon, it is methyl group. So what we will write here? 3 methyl, then 4, 5. Now 5 is 1 and 2 carbon and 5 hydrogen. So not ethane but ethyl. 3 methyl, 5 ethyl, and then we will see 1, 2, 3, 4, 5, 6, 7, 8, 9 non, all single bond, nonane. Clear? No other functional group, so directly root word and primary suffix. If some group alcohol or aldehyde is there, then we are in need to add. So this is 3 methyl, 5 ethyl, nonane. Clear? So I think you are getting the complete idea one by one. Still other rules we are there. We will see in our next video. By the time, practice and go through the videos properly. Thank you.